Hi friends, welcome to the Unit 3 Day 5 notes. Today we're going to be talking about angle relationship and logic with properties of kites and trapezoids. So these are special quadrilaterals, kites and trapezoids. So a kite is a quadrilateral with exactly two pairs of consecutive congruent sides. Which means, if I was to draw a picture of a kite, most people think about a kite like this, where it's kind of like a little tiny part up the top, and then at the bottom of it, it's a little bit longer, and that's actually what a kite is. Now remember, kites don't have to be shaped this way. If I rotated it or turned it, it's still a kite. And often the examples that we have aren't up and down vertically like the kites that you're used to seeing, but sometimes lying on its side like that. So just keep in mind. Consecutive means one after another, and then we've already talked about congruent. So it has to have exactly two pairs of consecutive congruent sides. A trapezoid is a quadrilateral with exactly one pair of parallel sides. Oftentimes we see a trapezoid where it looks something like this, where the larger side is on the bottom and the smaller side is at top. Doesn't have to be like that. Let me draw my parallel markings. It can also be on its side, as we say, on its side. There's really no side that it can be on, because remember we can rotate it. But there's another example. We call the parallel sides, we call those bases generally. So there's a base and there's a base. So just know that those are called bases, and then these parts are called the legs of the trapezoid. An isosceles trapezoid is a quadrilateral with, so it's a isosceles trapezoid is a quadrilateral with, it's actually a trapezoid. We're talking about something a little bit more specific. So this is an isosceles trapezoid, we're saying that that's a trapezoid, so all the definitions of a trapezoid, so exactly one pair of parallel sides with congruent legs. And so I talked about what a leg was on the previous one. So now, if I draw this out, now what I have is these two side lengths here then are congruent, and then these two sides are parallel to one another. And now we can do some theories, some properties of kites with this information. So if a quadrilateral is a kite, then its diagonals are perpendicular. Its diagonals are perpendicular. Perpendicular. There we go. So I drew the kite here already, so that means that if I connect this side and this side, then what I have is a right angle. So that means that AC, so the segment AC is perpendicular to the segment BD, like that. So there's that one. And then if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. So what that means, in this diagram here, you can kind of make it out. If I measure the angle between, if I measure angle B and angle D, those two angles are going to be exactly the same. And it kind of makes sense picture-wise. A doesn't necessarily have to be the same size as C, and it won't with a kite. Like, it can never be. That's why we said the word exactly. It's because if you think about like the distance between A and B, B and C, so that angle measurement here is going to be the exact same as this one, because I kind of have this reflection symmetry. Like I could fold this across this and it would match up perfectly. Think about a kite. If you folded a kite, one way it matches up perfectly, but the other way it doesn't. So that's another way to think about it. So angle B is congruent to angle D, and angle A is not congruent to angle C. So that's important to know. It is not congruent. And then my isosceles trapezoids, I have a few more theorems. If a quadrilateral is an isosceles trapezoid, then each pair of base angles are congruent. So refer back to the other page if you need to see what the bases are. But here, B, I was going to use it. I'll just use this color for this part. So B, if I say B and C are congruent, angle B and angle C are congruent, and angle A and angle D are congruent. So angle B is congruent to angle C, and angle A is congruent to angle D. If a trapezoid has one pair of congruent base angles, then it is an isosceles trapezoid. Now we're going the other direction. So if I have a trapezoid and then it has congruent base angles, which is what we talked about right here, then it has to be an isosceles trapezoid. And I forgot how to spell isosceles. Good thing it's right here. It's an isosceles trapezoid. So here, I know that then AB is congruent, segment AB is congruent to segment CD. Segment AB is congruent to segment CD. And a trapezoid is isosceles if and only if its diagonals are congruent. Remember, the diagonals are what's drawn from one point to the opposite point. So these segments here, the entirety of it. So I can't draw actual lines, segment congruent marks, because then it just looks like up here to whatever that that intersection point is. So AC, segment AC is congruent to segment BD. So if the diagonals are congruent, then it's an isosceles trapezoid. The last part I have, the mid-segment of a trapezoid. So this is the segment whose endpoints are the midpoints of the legs. So if you think about, if I have a trapezoid, like so, and then I'm going to connect here and here. So the midpoint between these two, so if I think about the midpoint here and here, then the midpoint here and here, because again, this doesn't necessarily have to be congruent. So the midpoint then, the mid-segment, excuse me, is then what cuts across that. So I have this, then here. Ooh, that's a terrible line. That is a terrible mid-segment. Let me fix that. Let's try that again. Something catching on my table. So that is the mid-segment then. And then this mid-segment, trapezoid mid-segment theorem, the mid-segment of a trapezoid is parallel to each base. So this is parallel to each base, and its length is 1/2 the sum of the lengths of the bases. So the length of this means if I add the length of AD and BC and then divide by 2. So another way of thinking it is like it's the average of the two. Join me in the next video where we then go over some examples using all of these different theorems and definitions that we just made up. We didn't make them up. They actually existed. We just put them on the paper. Have a wonderful day.